Hello, my name is Phillip Clendenin, and this is the third lab for Physics 2212 at Georgia Tech, focusing on the magnetic field of a bar magnet. In this experiment, we were given instructions to follow in regards to creating a real-life demonstration of a magnetic field using an app on our phones, and I will get to the important aspects shortly. However, this lab as a whole will go further into calculating the magnetic dipole moment as well as producing a glow script in form of a 3D model. By using the information we learned and equations have gathered, such as Biot-Savart's law, we are able to write lines of codes that can do the calculations for us. Now, getting back to the specifics of the real-life experiment, we are focused on measuring the magnetic field of a small bar magnet that we received in class. While this may seem simple at surface level, it is not the only magnetic field acting on the surroundings or the system, as the magnetic field of the Earth and the North Force emits always exist as well. However, because the location changes, we know that this magnetic field is not a constant force. Depending on where we are in the world, the magnetic field or magnetic force may differ in magnitude, but for Atlanta, Georgia, it is for roughly 49. Before we continue on, this is my spreadsheet that corresponded to the lab. The calculations or recordings or measurements of the left side of the sheet correspond to the on-axis measurements, while the measurements on the bottom half are related to the perpendicular or off-axis calculations or measurements. At this point, we are going to do a calculation to determine the magnetic dipole moment. To do this, we are going to be using multiple equations, and then we are going to rearrange them to find the dipole moment. We will be using the data from the y-intercept as well as the slope that is generated from the graph on our Excel spreadsheet, which is once again produced from our measurements. And doing this, we get our dipole moment to have a value of 11.61. Before getting back to the focus of the lab, we need to determine which of the four statements listed on the screen are valid based on our experiments, and which of the four claims disagree with what we saw. Of these four, we only witnessed the first and fourth claim to be true. When we moved the magnet far away from the magnometer, or vice versa, it really doesn't make a difference. We realized Bx to be approaching 0. However, as we moved the magnet and the magnometer closer, Bx increased significantly. Continuing on to the coding section of the lab, we are going to use the value we got from our magnetic dipole moment calculation to further demonstrate the magnetic field of the bar magnet. Before discussing the code, we need to understand the level of precision that the given equation can hold. While this isn't extremely accurate, as our distance of our R vector becomes extremely large or very far away, we also know that when we are really close to the resulting object, it has less precision, to a point that is more of a simplification or for understanding. This is where our coding will come into play to help remove some of that bias. Once our glow script code has been run, we were supposed to have a calculated value for the magnetic field produced by the dipole, referencing the formula that we just discussed. From this, we are going to demonstrate the magnetic field with arrows and sources, specifically the two locations that correspond to the axis of demonstration and the four locations that are perpendicular to this axis. Also, in this glow script demonstration or model, we have another axis that is tilted at a 45-degree angle from the axis of the bar magnet. This was all originally the plan, however my code produced an error over and over in the same location. I could not figure it out, but I understand that the field is supposed to run around the center magnetic bar, which is going to be a cylinder up and down, and there are going to be 2 on-axis locations and 4 off-axis locations. Finally, getting to the conclusion of the lab, or the 2 what-if questions. If we hadn't oriented our experiment to compensate for the original magnetic north, instead we just used a meter stick with respect to the Earth's magnetic field, our results would have changed primarily in the form of our measurements for Bx would be off. Because we are not accounting for magnetic north, it's going to be skewed in that direction slightly, and the effects of Earth will not fully be accounted for, allowing our intermediate calculations to be incorrect, causing a cascading negative effect in our glow script. Continuing on to the second what if we simply ran the experiment over again, however the focus was 2 magnets attached to each other end to end, our results or measurements would differ in regards to the degree of difference of the dipole moment, which is going to be approximately double. Because the magnets are end to end, the direction of their field does not change. Because of this, we can simply expect the calculations to change in a degree of size difference. In this case, because it is another magnet, is at approximately double, and that is how it affects the overall dipole moment. That's all for this lab. Thanks for watching.